So today I want to talk to you about a study that I'm starting looking at comparisons of living communities with dead shell assemblages, freshwater mussels in the family Unionidae, starting in the Great Lakes and beginning to understand anthropogenic impacts on these communities. My name is Mariah Scott, and I'm a PhD student from the University of Chicago. My advisor is Rüdiger, who's a mollusk curator at the Field Museum. We work with imperiled animals. Unionids are one of, if not the most imperiled families of animals in North America. They are incredibly sensitive to changes in water quality in the environment, so much so that we use their survival as an indication of changes, and even their behavior in real time as an indication of changes in water quality. For example, some really exciting research is coming out of North Carolina State University, actually looking at the opening and closing of shells to get a real-time indication of changes to water quality. So it is not surprising that they have been declining over time, and that includes the Great Lakes region, and they have been declining for longer than we've really been systematically studying their decline. They have been impacted by so many different causes. I did kind of like a word cloud of some of the major causes that have been described in several publications. You can see it's a lot of things like alterations to the habitat, destruction of the habitat, degradation of water quality, increasing in pollution, damming, for example, or changes in abundance of their host fish. And we care about this. That's why we're in the Freshwater Mollusk Conservation Society. So a lot of work has been put into monitoring these populations in real time, monitoring and understanding these causes of decline and how we can fix the problem to the best of our ability. But what about before we started paying attention? These animals have been impacted for so much longer. We've all seen those historical pictures of people sitting on these mounds of collected shells for the button industry. So yeah, what was happening to these populations before we began monitoring them, before we knew some major change had taken place, and maybe we didn't survey an area as thoroughly as we would have if we had known a major change was about to take place. Or even, what was it like before Europeans? What was it like before humans were in the area? For questions like this, conservation paleobiology can provide some methods to begin to understand this. It uses geologic and paleoecological records to inform conservation of biodiversity and restoration of ecosystem services. Essentially, you're using the data from a water body to give you an idea of what it was like in the past. So an example would be a study where you're comparing the shell material in the water body to more recent shell material, or maybe the living animals in the water body, to better understand changes in biodiversity. You can look at changes in community composition, species richness, which is the number of species you were finding before and after, and species evenness, which is an indication of how biodiverse was the ecosystem before and after. Did you, for example, have a nice mix of species, which would be associated typically with a healthier environment? So I utilized data from the Unionidae Refuge Project, which were surveys that were done in 2011 and 2012. I actually got to be a part of it, which is super exciting. They took place across the Great Lakes region. We set up half-hectare survey sites and surveyed them for 2 person-hours each, and then did multiple sites per water body. We collected all the live unionids and identified them, and then at the back. We also did the same with the shell material. Now, we weren't digging deep for shell material. We're getting the shells kind of on the top of the substrate, the top surface layer. So this would represent relatively recent shell material overall. Which means that the comparisons I'll be doing are between living animals and relatively recent shell material. We also took environmental data, including a kind of a qualitative assessment of Dreissena density, so zebra aquatica mussels. How much of them were we seeing? So the study I'm talking to you today about is utilizing the survey data to make comparisons between shell material and living animals in a water body to better understand changes in biodiversity. I was looking at changes in community composition, changes in species richness, and changes in species evenness. I'm also interested in using environmental data and possibly historic data to determine which anthropogenic impacts are associated with the biggest changes in community composition, species richness, and species evenness. This is preliminary data of a study that I am building on. So I utilized data from 34 different water bodies in the Great Lakes region. The amount of survey time was often relative to the size of the water body, with the water bodies representing 4 to 34 person hours worth of search time. I rarefied the data to make equal comparisons between the number of living specimens and the number of shells of a given water body that we were comparing. For example, if we found more shells than living animals, I subsampled the shells without replacement to make it a more equal comparison. I was looking for the amount of agreement between living specimens and shell material and the water body, so essentially an agreement in the community composition, as well as what was the change in measures of community composition. So species richness, Shannon diversity index, which is a measure of kind of the abundance and evenness of the species, and then Pailou's evenness. So in terms of agreement of community composition, here we have the comparison of Chow-Jacquard similarity index with the Spearman-Rowe pairwise comparison of each water body. And by that, I mean you're comparing what we were finding in the shell material and what we were finding in the living animals. Chow-Jacquard similarity index, the y-axis, is looking at, are the same species present before and after? So shell material versus living animal. And you can see overall, on average, there was a lot of agreement in which species were present before and after. And then the Spearman-Rowe pairwise comparison is looking at, in the water body, do you have the same rankings of species? If you ranked the species most to least abundant, are they staying consistent? So do you have the same species be dominant in the shell material as well as the living animals, and be rare in the shell material as well as living animals, or are there changes? So the takeaway is that similar ranks have been maintained. If you're dominant in the shells, you were very likely to be dominant in the living animals, for example. But there have been some changes in which species are present, with a lot of water bodies having an extirpation of certain species. But overall, there was a lot of agreement in the community composition between the live animals and the recent shells. So the blue circle represents areas that had a lot of agreement in both who was there and what rankings they had. And then the orange is where there was some agreement in which species were there, and I'm sorry, some agreement in what the rankings were of the species, but changes in which species were present. I was interested to see if the kind of qualitative assessment of Dreissena at each site averaged for each water body would give any indication of pattern. Wasn't really seeing that. Was also interested in maybe if a water body had more specimens that we were comparing, if that had higher agreement. And I was seeing there seems to be some pattern where if you have more specimens, you had higher agreement in community composition, but there is kind of a mixture. In terms of changes in community composition measures, where I took the live animals found, did a measure of community composition, and then minus that from what we found in the shells. So that would be an idea where if it's a negative value, we're seeing a loss. So for example, on average, we saw a loss in species richness with more species represented in the shells than the live animals. And then we also saw a loss in Shannon diversity indices on average, as well as Pailou's evenness. I was kind of curious to see if Dreissena species density was something that would be correlated with these changes. Didn't find any significance there, but this is a chance to look at the data with the vertical lines being 0 or no change in kind of the before and after. We're seeing that overall water bodies had drops in these measures. And if there was an increase in what we were finding in the live compared to the shells, that was often associated with smaller sample sizes of the number of specimens we were comparing in these water bodies, with the points on this graph being an indication of how big the sample size we were comparing for a given water body. So in the future, I'm hoping to add additional survey data. I would like to utilize the data that I do have where we did not find both live animals and shell materials in a water body to compare the before and after. I would also like to explore other anthropogenic impacts. Dreissena density was just kind of the first pass that I wanted to look at, but I'm hoping to better understand changes in community composition, species richness, and species evenness, which anthropogenic impacts are associated with the biggest changes. I'd also like to utilize historical surveys as well as possibly museum collections for these kind of comparisons. My funding is through the University of Chicago as their grad student, and Sue Kidwell and Dave Jablonski have been very helpful in offering advice for this project so far. But I would also like to thank the Unionidae Refuge Project, all the funding sources for that project, as well as governments and nations that gave us permits or access to water, as well as all the amazing people I got to work with for being a part of the Unionidae Refuge Project. I would like to give a special shout out to Dr. Dalen Woolnough, who was the real person pushing us to collect shell material when I myself did not quite see why we were doing this. I now get it, so thank you. If you have any questions or comments, I really look forward to hearing them. I'm also interested in potential collaborations. If you have any data that you would like to have analyzed with these methods, give me an email. And I hope you all are having a good day.